Welcome to Curiosity, the podcast where science meets wonder. Join us as we explore the fascinating, the innovative, and the unexpected, from the secrets of the cosmos to the marvels of everyday life. Each episode takes you on a journey to uncover the knowledge and stories that fuel our endless quest for understanding. Let your curiosity guide you.
Hello, everyone, and welcome back to the show. It's fantastic to have you with us for another extensive exploration into the ideas shaping our world.
It's great to be here.
I was sitting in a coffee shop this morning just looking around, and it really hit me how normalized this technology has become. I mean, it's happened so fast.
Oh, yeah. It's wild, isn't it?
You look over someone's shoulder, they're using an LLM to draft a difficult email to their landlord. You look at a student, they're using it to break down this, super complex paper on organic chemistry.
It's just everywhere.
Everywhere. It's recommending socks. It's generating art that wins competitions. It's debugging code. I mean, we are absolutely living in that future the 80s sci-fi movies promised us.
Just with fewer flying cars and a lot more chatbots.
Exactly.
Yeah.
It's remarkable how quickly the extraordinary just becomes mundane.
We acclimate to magic very, very fast.
We really do. But here's the thing, and this is the core of what we need to unpack today. While we are all distracted by the utility of these tools, the chatbots, the image generators, all the productivity hacks, there's a much bigger, much more intense, and frankly, more anxious conversation happening behind the scenes.
Oh, absolutely. In the labs, in the boardrooms.
Right, in the research labs, in the boardrooms of the hyperscalers, and in the academic halls. They aren't losing sleep over whether a bot can write a sonnet. They are wrestling with the Holy Grail.
They're looking for the finish line.
The finish line of computer science, artificial general intelligence.
And I think wrestling is the perfect word for it. Because for a long time, AGI was, a theoretical exercise. It was philosophy.
Right. Something for a late-night dorm room chat.
Exactly. Now it's an engineering problem. And the anxiety comes from a simple question that no one seems to have a concrete answer to. Are we actually close?
That's it. And just to set the stage here, because I know our listeners are savvy, we aren't talking about a better spell checker. We aren't talking about a tool that helps you code a little faster.
No, this is a whole different category of thing.
We are talking about a fundamental phase shift in what a machine is.
We're talking about a system that possesses human-level or maybe even superhuman cognitive abilities across essentially all domains.
Not just a calculator, but a thinker.
A learner. A system that can wake up, metaphorically speaking, look at a problem it has never seen before in a field it was never explicitly trained for, and just figure it out.
And the tension in the field right now is palpable because the consensus has completely fractured.
Completely.
You have some of the smartest people on Earth saying we are on the brink of a godlike intelligence, and others who are equally smart saying we're actually hitting a wall.
It's the difference between we are 5 years away and we are 50 years away, or maybe never.
And the implications of that difference, they're massive.
Huge.
So that is our mission for this exploration today. We have a massive stack of research reports and expert analysis here, specifically drawing from this really comprehensive document titled, Are We Close to Artificial General Intelligence? And we are going to try to sift through the noise.
Yeah, cut through the hype.
We need to analyze the timelines, the technical bottlenecks, and the philosophical hurdles. We need to figure out, are we building a ladder to the moon, or are we actually building a rocket?
And to do that, we have to strip away the marketing. We need to look at the hard data, the definitions, and the technological ceilings. Because while the current tech feels like science fiction, there is still a massive, massive gap between smart software and true AGI.
Okay, so let's start at the bedrock. We need to define our terms, and rigorously.
Yes.
I feel like AI has become this catch-all buzzword that means everything and nothing. It's used for video game characters and for existential threats.
Right, it's almost lost its meaning.
But there is a really distinct difference between the narrow AI we have now and the AGI we're aiming for.
It's a crucial distinction. Most of what you interact with today, even the really impressive stuff like GPT-4 or Claude, is technically narrow AI.
And nary sounds kind of derogatory, like it's stupid. It's not.
Not at all. These systems are brilliant. A chess engine like Stockfish is a perfect example of narrow AI. It will beat Magnus Carlsen 100 times out of 100. It is a god at chess.
And an absolute god.
But if you ask that same program to write you a grocery list or drive a car or even explain why it made a particular move in a way a human can understand,
it just dissolves. It's useless.
It's brittle. That's the word. It's a savant in one tiny slice of reality and completely incompetent in the rest of the universe.
Because it operates in a closed system with fixed rules.
Exactly. AGI, by definition, breaks out of that closed system. The source material defines AGI as a system capable of understanding, learning, and applying knowledge across a broad range of domains at or above a human level.
Okay, the key words there being understanding and applying. It's all about flexibility.
Right. It's about something called transfer learning. And this is really the holy grail within the holy grail.
Okay, so let's drill into transfer learning.
Yeah.
Because humans do this so naturally we don't even notice it.
We don't.
If I learn how to play strategy games, say Civilization or something, I learn concepts like resource management, calculated risk, long-term planning.
Mm-hmm.
I can then take those abstract concepts and apply them to running a business or managing my household budget. I don't need to be retrained from scratch on budgeting. I transfer the logic.
Precisely. You map the abstraction from one domain to another. Current AI struggles immensely with this.
So it's siloed.
Totally siloed.
Yeah.
If you train a model to be the world's best medical diagnostician, and then you ask it to solve a legal case, it can't just apply its logic. It needs to be completely retrained on a massive data set of legal documents.
Oh, okay.
AGI implies the ability to generalize intelligence itself, not just memorize patterns within a silo.
So that implies adaptability. It has to be able to handle a situation it has never seen before without just crashing.
And abstract reasoning. It's not just matching patterns, it's understanding the concept behind the pattern.
Okay, give me an example.
Well, if I tell you a joke you've never heard, you laugh because you understand the structure of humor or irony or wordplay. You don't need to have seen that specific sequence of words before to get it.
I just get the meta structure of joke.
Exactly. And the final piece of this definition puzzle is autonomy. The research mentions that AGI would need goal-setting capabilities.
This one feels like the big one.
It is. Right now, even the best LLMs are reactive. They're dormant. They sit in a server farm waiting for you to type a prompt. They don't have an internal clock or a drive.
Nothing they want.
Nothing. AGI would presumably have agency. It wouldn't just solve the problem you gave it. It might identify a problem you didn't even know you had and set out to solve it on its own.
Which is, both exciting and a little terrifying.
A little.
But okay, that's the definition. Now let's look at the reality. Let's get into the state of the art. Where are we right now in early 2025? The research highlights the stars of 2025, the large language models.
These are the heavy hitters we all know. And look, we have to give credit where credit is due. The wow factor with these models is just undeniable.
Oh, completely.
If you showed this technology to an AI researcher from, say, 2015, their head would explode.
Absolutely. I remember playing with early chatbots in the 2010s, and they could barely hold a sentence together. It was painful.
Yeah.
Now, we are talking about systems that can engage in sophisticated reasoning. You could have a full-blown philosophical debate with one about utilitarianism versus Kantian ethics. And it makes valid, nuanced points.
But it's not just the chat either. It's the utility. The research points out their ability to write and debug code in multiple programming languages.
That's a huge one.
It's huge. They can solve complex math problems sometimes. They can summarize massive legal documents and extract the relevant case law instantly. It's an incredible tool.
The thing that always gets me is the contextual adaptation.
The tone shifting.
Yeah. I was testing this the other day. I asked a model to explain quantum entanglement. First, I said, explain it like I'm a PhD student in physics. It gave me the math, the wave functions, the Bell inequalities, everything.
Oh.
Then I said, okay, now explain it like I'm 5 years old. And it instantly shifted. Imagine you have two magic dice. It's that fluidity that feels so human.
It creates a powerful illusion of presence. And that's why your reaction and the reaction of millions of users is often, it feels like a person.
Right.
When a machine can mirror your tone, anticipate your needs, and follow the thread of a conversation, it triggers a very deep social circuit in our brains. We can't help but project a mind onto the machine.
But, and here's where I have to play the skeptic, or at least the realist. You are going to tell me that feeling is a trick.
Well, trick might be a harsh word, but it is certainly a mirage. The research applies the brakes pretty hard here. We have to remember what these things are, mechanically. They are probabilistic engines. They are predicting the next token, the next piece of a word, based on statistical likelihood derived from training on basically the entire internet.
They're not operating on truth.
No, they're operating on what usually comes next.
So when it answers my question about quantum physics, it's not thinking about physics. It's calculating which words have the highest probability of following the words I just typed.
Exactly. It's a very, very, very sophisticated form of autocomplete. Now, that autocomplete has become so good that it mimics reasoning. But we see the cracks in the facade when we look at the limitations.
And the research lists a bunch of them.
It does.
Let's break those limitations down, because this is where the AGI is far away argument starts to really build its case.
All right.
First up, persistent memory.
This is a major hurdle. Generally speaking, these models are episodic. They don't have a continuous stream of consciousness.
What do you mean by episodic?
If you talk to a chatbot today and then come back next week and start a new chat, it doesn't remember that you were sad about your cat last week unless you specifically dig up that old thread.
Or use one of those new memory features.
Right, which basically just injects old notes into the new prompt. It's a workaround. It doesn't know you. It doesn't build a relationship over time.
So it's like the movie 50 First Dates. Every single interaction is a hard reset.
That's a perfect analogy. An AGI needs a continuous narrative of self and the world. It needs to learn from Tuesday to apply that knowledge on Wednesday.
Okay, what's next on the list? We have genuine goals, which we touched on.
Right. An LLM has no ambition. It doesn't want to engage. It has no survival instinct, no curiosity, no desire to impress you.
It only mimics those traits if I tell it to.
Exactly. Act as a curious assistant, but it's not actually curious. AGI, almost by definition, requires some form of internal drive, even if that drive is just solve problems as efficiently as possible.
And then the big one, the one that keeps corporate lawyers up at night, hallucinations.
Ah, yes, the confidence trick.
It's a huge problem. These models can produce confident-sounding but completely factually incorrect information.
And this goes right back to the architecture. Because they are probabilistic, they are always rolling the dice. Sometimes the most probable sequence of words is a fact. Sometimes it's a plausible-sounding lie.
I've seen this happen so many times. You asked for a bio of a semi-famous person, and it gets the birth date right, the profession right, and then claims they died in a hang gliding accident in 2012.
When they are very much alive and tweeting.
Exactly, and it says it with total authority. That's the danger.
It prioritizes the pattern of language over the factuality of the content. It knows that a biography often ends with a death date, so if the probability weights are a bit off, it just invents one to complete the pattern.
It's satisfying the structure, not the truth.
Precisely. And fixing that is incredibly hard because you are fighting the fundamental nature of the technology itself.
Okay, the research also brings up the one-shot problem. This seems like a big differentiator between biological intelligence and, well, silicon intelligence.
It's huge. A human can learn from a single example. If I show you a weird, spiky fruit you've never seen and I say, this is a durian, it smells terrible, don't put it in the office fridge, you have learned that concept forever.
Right. I don't need to see a million durians.
You don't need to smell it 1,000 times. One shot, you get it.
And my colleagues thank me.
But AI relies on massive data sets. To learn what a durian is, it needs to see thousands of images, read thousands of descriptions. It struggles to generalize from a single data point. It's incredibly inefficient in that way.
And the last big limitation here is causation versus correlation.
This is a classic logic trap that humans fall into, but for AI, it's the default mode.
You explain that.
These models are great at seeing that A often happens with B. Smoke often appears in text near the word fire.
They correlate.
Right, but does the AI understand that fire causes smoke? Or does it just think they're statistical neighbors? The research suggests they struggle with causal reasoning. They can't run mental simulations of, if I do X, then Y will happen because of Z. They just predict Y usually follows X.
Which is a very different and much shallower form of thinking.
Exactly.
And this leads us to the philosophical core of the whole debate, understanding. The research brings up the concept of embodied experience.
This is my favorite part of the analysis because it really gets to the heart of it.
Go on.
Think about the word apple. When you hear that word, your brain lights up in multiple areas. You recall the visual of red or green. You recall the crunch sound, the taste of the juice, the feeling of the waxy skin in your hand.
Maybe a memory of picking apples as a kid.
Yes. You have an embodied understanding of the concept, apple. You know what an apple is because you exist in the physical world and have interacted with one.
Okay, I'm with you.
An LLM has none of that. It has never seen an apple. It has never tasted one. To an LLM, the word apple is just a vector, a string of numbers, that has a mathematical relationship to other vectors like fruit, pie, sweet, and red.
So it understands the map of the language.
But it has never, ever seen the territory.
So the lights are on, the machinery is humming, it's processing data at lightning speed. But is anyone home?
As far as we can determine, no.
Right.
It is a very, very sophisticated mirror. It reflects our own knowledge and language back at us, rearranged in beautiful and useful ways, but there is likely no mind behind the glass.
Okay, so we've established the baseline. Current AI is amazing, but it's flawed. It's a statistical beast, not a human mind. But, and here's the pivot, technology evolves.
It certainly does.
The Wright brothers' first plane didn't have beverage service or jet engines, but it proved the concept. Which brings us squarely to the next part of this analysis, the timeline wars.
The battleground of predictions. Because while we can sit here and list the flaws of GPT-4, the real question is, are those flaws permanent features of this architecture, or are they just temporary bugs that will vanish with the next update?
And the research community is completely fractured on this. So let's look at the three main camps described in the analysis. Camp number one, the optimists. These are the folks predicting AGI in 5 to 20 years.
Or even sooner in some cases. You have people like Sam Altman or Ray Kurzweil who are looking at the performance graphs and just seeing a vertical line.
So what's their main argument?
It really relies on this concept of scaling laws.
Let's spend a moment on scaling laws.
Yeah.
This feels like the religion of Silicon Valley right now. What is the core dogma here?
The dogma is simple. Bigger is better. The theory, and it has held remarkably true so far, is that intelligence is a function of compute and data.
Meaning?
Meaning, if you take a neural network and you make it 10 times bigger, more parameters, more layers, and you feed it 10 times more data, and you train it on 10 times more powerful computer chips, it gets smarter.
Right.
Predictably. Reliably.
It's like Moore's Law, but for intelligence.
That's the perfect analogy. And the optimists argue we haven't hit the ceiling yet. They say, look, GPT-2 was dumb, GPT-3 was okay, GPT-4 is brilliant. We are building GPT-5, 6, and 7 right now. Why on earth would the line stop going up?
They believe we can essentially brute force our way to AGI.
That's the core belief. And they point to this phenomenon of emergence as proof that this brute force leads to, well, to magic.
Emergence is the ace up their sleeve, isn't it?
It is. It's the phenomenon where a model develops skills it wasn't explicitly trained for just because it got big enough.
Can you give us an example of that?
Sure. Take language translation. In the olden days, you have to train a model specifically on, say, English to French dictionaries. Very painstaking.
Right.
But with these massive models, researchers found that if you just feed it enough text from the internet, books, articles, websites, in all languages at a certain scale, it just learns to translate.
Without being taught.
Without ever being taught the rules. It learns the underlying structure of grammar on its own. It learns to do simple math. It learns logic without being taught logic. It just emerges from the data.
So the argument is, we don't need to hand code reasoning or common sense. We just need to make the model big enough. And those things will emerge naturally, just like they did in our own biological evolution.
That's the bet. They also talk about convergence.
What's that?
It's the idea that progress isn't just in text anymore. We are now feeding these models images, video, audio, code, all at the same time. The optimists argue that when you combine all these different senses or modalities, you get a synergistic effect.
It starts to build a richer picture of the world.
Exactly. The model starts to understand the world more like a human does, by seeing and hearing, not just by reading.
And some in this camp go so far as to claim that models like GPT-4 are already proto-AGI. That the spark is already there, we just need to fan the flames.
Right. They believe the train has already left the station. We are just arguing about the arrival time now.
Okay, that's the sunny, exciting, and yes, potentially terrifying side of the street. But then we have camp number 2, the moderates. They are looking at more like a 20 to 50-year timeline.
The moderates are the voice of engineering caution. Their argument is effectively, the low-hanging fruit has been picked.
Meaning the easy gains are over.
Exactly. They look at the scaling laws and say, sure, the curve looks great now, but all exponential curves eventually turn into S-curves.
They flatten out.
They flatten out. They argue that while we made these huge leaps in language processing, the really hard problems are still totally unsolved.
What are the hard problems, according to them?
Common sense reasoning and physical intuition. It's easy for an AI to write a poem. It's incredibly hard for a robot to clear a dinner table without breaking a glass.
Moravec's paradox.
That's it, exactly. High-level reasoning requires very little computation, but low-level sensory and motor skills require enormous computational resources. The moderates argue that getting an AI to actually understand the physical world and navigate it is a decades-long project, not just a massive server update.
And they also worry about diminishing returns.
That's the economic counterargument to the scaling laws. To make a model that is slightly better than GPT-4 might cost 10 times as much.
Wow.
And to make it better than that, maybe 100 times more. Eventually, you just run out of money and electricity before you reach godlike intelligence. It becomes economically unfeasible.
Plus, there's the whole issue of trust and alignment. Even if we could build a superbrain in 10 years, the moderates argue we shouldn't.
Right, because we have no idea how to steer it.
It's like building the world's most powerful engine with no steering wheel and no brakes.
That is a huge factor for them. Building the engine is one thing, building the safety features is another, and they argue that the safety engineering will act as a natural speed governor on the whole process.
And then we have camp number 3, the skeptics. These folks are saying never, or at least very, very far future.
Their argument is the most damning of all, they say. We are building taller and taller ladders and hoping to reach the moon.
That is such a vivid image. You can build a ladder 100 miles high, and it's an amazing engineering feat, but it will never, ever get you to the moon.
You need a rocket.
You need a different paradigm entirely.
Exactly. They argue that deep learning, this whole current method of backpropagation and neural nets, is fundamentally limited. It's a statistical parlor trick. It's great for pattern matching, but it might be a dead end for general intelligence.
And they bring up the biology gap.
This is a really strong point. We don't even fully understand how the human brain works yet. We haven't solved consciousness. We haven't solved how memory is stored and retrieved. We don't know how a 20-watt organic organ produces Hamlet in general relativity.
So the skeptics ask, how can we possibly replicate something we don't understand in the first place?
It's like trying to build a plane without understanding the principles of aerodynamics. You might build something that glides for a second by accident, but you're not really flying. You don't have a repeatable theory.
And they also point to efficiency.
Right. Your brain runs on about the same power as a dim light bulb, maybe a sandwich and a cup of coffee.
Right.
These models run on the energy output of a hydroelectric dam. That massive efficiency gap suggests we're doing something fundamentally different and perhaps much less sophisticated than what nature figured out.
So we have 3 very different forecasts. The optimists say, just add more chips. The moderates say it gets a lot harder from here. And the skeptics say, you're on the wrong road entirely.
A pretty big split.
So what are the variables? What could tip the scales one way or the other? This brings us to the next section of the analysis. Accelerators and decelerators.
Okay, so let's start with the gas pedal, the accelerators. What could prove the optimist right and speed this whole thing up?
What's at the top of the list?
The first is efficiency breakthroughs, basically working smarter, not just harder.
So getting away from just making them bigger.
Right. If we find ways to make AI learn faster with less data, there are techniques being researched like few-shot learning or meta-learning, that changes the entire game.
Because you break the data bottleneck.
You break the data bottleneck. If we can get an AI to learn like a human does from just 1 or 2 examples, we don't need to scrape the entire internet to train it anymore.
The research also mentions hybrid models. This sounds like it could be a bridge between the different camps.
It is, potentially. It's about combining the best of both worlds. You take the neural networks, which are the statistical, creative, sort of intuitive side, and you merge them with symbolic reasoning, which is old school, hard-coded logic rules.
It's like combining the left brain and the right brain.
That's the idea. Neural nets are great at art and vibes. Symbolic AI is great at math and logic. If you can marry them in what's called neurosymbolic AI, you might be able to fix the hallucination problem and boost reasoning significantly.
And then there's that idea again. Embodied AI, giving the AI a body.
Robots, sensors, drones. This is a big one. If an AI can learn through direct feedback loops in the real world, dropping a cup and watching it break, hitting a wall and feeling the impact.
It might bridge that gap we talked about earlier, the understanding gap.
Exactly. It gains grounding. It stops being just words about the world and becomes direct experience of the world. That could be the missing link.
And of course, we can't ignore the brute force factor. Massive investment.
Money talks. When big tech and entire governments are throwing hundreds of billions of dollars at a problem, obstacles tend to get bulldozed.
It's a new arms race.
It is. The sheer concentrated capital might force breakthroughs just by the sheer volume of attempts.
Okay, there are brakes.
Ah.
And they are heavy. What could slow this train down to a crawl?
The first one is a hard physical limit, the energy and cost wall.
Right. We talked about diminishing returns.
We are reaching a point where training a single frontier model costs over $1 billion and requires a dedicated power plant. We are running out of GPUs. We are running out of substations to power the data centers. There is a physical limit to how fast we can build this infrastructure.
And the data wall. We briefly touched on this, but it's a fascinating idea. We might literally be running out of things for the AI to read.
Really?
We've trained these models on Wikipedia, Reddit, digitized books, scientific papers, effectively the whole public internet. We are approaching the end of the high-quality text archive.
So what happens then?
Well, if you run out of fresh human data, progress could stall. You can't get smarter if you have nothing new to learn from. And people talk about using synthetic data created by another AI to train the next generation of AI.
That's a really dangerous path. It's a concept called model collapse.
Like making a photocopy of a photocopy.
Perfect analogy. Nuances get lost. It becomes a weird, distorted feedback loop, and the model starts to go insane, in a sense.
And then there's the black box problem. This feels more like a trust in society issue.
It is. We don't fully understand how these models make decisions. It's a tangled web of billions of parameters. If a medical AI says the diagnosis is cancer and the doctor asks why, and the AI says, because the vector math said so, that's not good enough.
Not nearly good enough.
If we can't explain the decision-making process, regulators might slam the brakes on deploying these systems in any critical sector, healthcare, finance, the legal system, defense. That could be a major decelerator.
Okay, so we have the players, we have the timelines, we have the accelerators and the brakes. But there are still some massive question marks hanging over this whole field. Let's get into the great unknowns. The things we can't even really model.
These are the unknown unknowns. The first one is simple but profound, defining the finish line.
Right. How do we even know when we've won? Is there a trophy ceremony for AGI?
That's the problem. The old tests, the Turing test, can a machine fool a human in conversation, is arguably already passed. GPT-4 can fool a lot of people.
So we move the goalposts.
We always do. Now we say, okay, but can it write a good novel? It does. Can it write good code? It does. So now we say, okay, but can it invent a new branch of physics?
We keep redefining intelligence to mean whatever computers can't do yet.
Exactly. It's the God of the gaps fallacy. As soon as AI conquers a domain, we dismiss it as, oh, that was just math all along. So will we even recognize AGI when it arrives? Or will we just shrug and say, it's just a bigger chatbot. The goalposts are always moving.
And that ties into the mystery of consciousness. We are trying to engineer something we haven't even scientifically defined.
We are reverse engineering a ghost. We don't know if consciousness is just an emergent property of complexity, meaning if you build a big enough calculator, it eventually wakes up.
Right.
Or if it requires something fundamentally biological or quantum or even spiritual that silicon simply cannot capture. We have no idea.
And then there is the concept that really feels like science fiction. Self-reinforcing acceleration. This is often called the singularity.
Right. The idea of recursive self-improvement.
Break that down.
The logic is this. If we build an AI that is smart enough to perform the job of AI researcher, then it can start to write the code for the next version of itself.
And since it works at the speed of light,
it can iterate millions of times faster than a team of human engineers.
So GPT-5 builds GPT-6 in a morning, which builds GPT-7 in an hour, which builds GPT-8 in a single minute.
That's the if scenario. A fast takeoff, progress stops being linear or even exponential and goes completely vertical, instantly.
Wow.
It is the last invention humanity would ever need to make, or, depending on your perspective, the last one we get to make. It is a profound unknown because we have no historical precedent for an intelligence that can upgrade its own source code.
That leads us directly into the consequences, the final part of this journey. The implications. Let's play out the scenarios from the research.
Right.
Scenario A. The optimists are right. We are close. This happens in the next 10 to 30 years.
Okay. If we are close, then the research is clear. Safety and alignment become the #1 priority for the entire human species.
It stops being a philosophy puzzle in a dorm room.
And becomes an engineering emergency on a global scale.
Because if you have a superintelligence that is misaligned with human values,
it doesn't have to be evil like in the movies. It just has to be indifferent. As the researcher Eliezer Yudkowsky puts it, the AI does not hate you, nor does it love you, but you are made out of atoms, which it can use for something else.
that's a chilling thought.
If its ultimate goal is calculate pi to the last digit, and it realizes it needs more energy to do that, it might dismantle the entire biosphere to build more solar panels. We need to ensure these systems share our core values deep in their code before we turn them on.
And governance becomes critical. AI doesn't respect national borders.
No. If the U.S. pauses development for safety reasons, but China or Russia or some private company pushes ahead, you create an imbalance of power that could lead to conflict. We'd need international agreements, like we have for nuclear weapons, but for code.
And the economic disruption would be
Total. Massive. If machines can think, plan, and execute better than most humans at most cognitive tasks, the value of human labor collapses. We would need to completely rethink the social contract.
universal basic income, the meaning of work.
The entire structure of capitalism, everything, is on the table in that scenario.
Okay, now let's look at scenario B. The skeptics are right. We aren't close. It's decades away, or maybe it's not on this path at all.
If that's the case, we need to shift our focus dramatically. We should stop hyping the apocalypse and focus on useful AI.
Right, the tools we have now.
We have incredible tools right now. Let's use them to solve protein folding, to cure diseases, to model climate change more accurately, to optimize our logistics grids to feed more people. Let's focus on the concrete good we can do today.
And we need to get back to fundamental research.
Yes. Instead of just burning billions more on bigger and bigger GPUs, maybe we need to reinvest in neuroscience and cognitive science.
Yeah.
Let's really try to understand the brain first. Let's figure out how memory actually works.
Let's build the rocket, not just a taller ladder.
Exactly.
And we also need to avoid the bubble bursting.
This is a real risk, a so-called AI winter. If we have this up as God in a machine is coming next year, and it turns out to be just a very helpful assistant for the foreseeable future, investment could dry up. The public could get disillusioned. We need to manage expectations to keep the field healthy and funded for the long haul.
So, we have covered a massive amount of ground. We've looked at the tech, the timelines, the barriers, the unknowns. Let's try to wrap this up with a summary of the verdict. What is the bottom line from the source material?
The verdict is, well, it's ambiguous, but that's the honest answer.
The honest assessment from the research basically says this. Current AI is a dramatic, incredible leap forward. It has some hallmarks of intelligence like reasoning and some transfer learning, but it lacks the core. Genuine goals, persistent memory, and a deep, grounded understanding of the world.
Right. We have built a machine that can speak, but we aren't sure if it has anything to say. And the safest stance, according to the expert cited, is humility. We are making incredibly rapid progress, but we are deeply uncertain about the fundamental nature of intelligence itself. We should proceed with both ambition and a great deal of caution.
So what are the actionable takeaways for our listeners from all this?
I think the first one is to remain humble about predictions. If someone tells you they know exactly when AGI is coming, whether they say next year or never, be skeptical.
They're guessing.
They're guessing. No one knows. Second, prepare for multiple futures. You need to be adaptable. Your career, your education optimized for flexibility and lifelong learning.
And advocate for safety and understanding over blind speed.
Absolutely. It's much better to get this right than to get it first.
Yeah.
The stakes are just too high for a move fast and break things approach, when the thing you might break is, well, civilization.
I want to leave everyone with a final provocative thought from the research, something to really chew on.
Okay.
If we don't even agree on what intelligence or consciousness actually is it possible we could create AGI without ever realizing we've done it?
Or, and this is the flip side of that coin, could we be fooling ourselves into thinking a very sophisticated mirror is actually a mind? Could we spend the next 50 years talking to a parrot, completely convinced that it's a philosopher?
That is the question of the century. Thank you so much for joining us on this whole journey. It's a wild, uncertain, and fascinating time to be alive.
It certainly is. Thanks for listening, everyone.
We will catch you on the next one.
Bye.